Now we have covered a lot of methods of factoring over the last couple lessons, and it's hard for students to figure out which method you're going to use in which circumstances, because every method only has one specific circumstance that they can actually be used in. So knowing which method of factoring to use is incredibly important. So here is your steps. Step 1, I always want you to try first, is to factor out a GCF. We've done that throughout all the different methods that we've tried. At some point would have to factor out GCF so that you don't forget GCF is always the method that you try first. After you've determined if there's a GCF or not and you factored it out, you're going to try to factor out whatever's left inside the parentheses if you factored a GCF out, or just if no GCF, you just have to keep trying to factor. And the next step you're going to do is you're going to ask yourself, how many terms do we have in the polynomial that we're trying to factor? And the three answers could be 2 terms, 3 terms, or 4 terms. If we have 2 terms, it's called a binomial, and in order to factor binomials, you need to use a formula. There are 3 formulas that we need to know. It's the a squared minus b squared, or difference of squares, the a cubed plus b cubed, or sum of cubes, and the a cubed minus b cubed. Now if your polynomial has 3 terms, that's called a trinomial. And we have 2 types of trinomials. We have where a is equal to 1, so the next question you're going to ask yourself, is the leading coefficient 1? If the leading coefficient is 1, we call that our easy trinomial, where it's x squared plus bx plus c. My easy trinomial. In this case, all you're going to do is set your skeleton answer up. You have x and x in the front, and you're looking for 2 numbers that multiply to the c term yet add to the bx term at the same time. So that's your easy trinomial. Now, what if a is not equal to 1? Well, if a is not equal to 1, that's of the form ax squared plus bx plus c, where a is not equal to 1, and I usually call these my harder trinomials. The reason it's hard is because that middle term is kind of hidden there. So these are my hard trinomials. In order to factor a hard trinomial problem, I gave you 2 methods. One method is guess and check, or you could use the AC method. Sometimes we call that grouping or split the middle term, because you're taking the middle term and splitting it. If you have 4-term polynomial, the 4-term polynomial doesn't really have a nice fun name like binomial or trinomial. It's just a 4-term polynomial. And the only way to factor 4-term polynomials is by grouping. So that's your second step. Decide how many terms it is, and this little flow chart can help you figure out which method you're going to pick. The third step is to ask yourself, is the polynomial completely factored? Because sometimes you factor using one of these methods, but there's more to factor. If there's more to factor, you need to keep doing that. Okay, go back, is there 2, 3, or 4 terms left? And keep doing it until each one of those terms is completely factored. Note, if nothing factors, not even a GCF, then we call the polynomial prime. Okay, for the following exercises, determine the method of factoring that should be used. Now, we're not going to do every single one of these problems, but I will give you the answers. The purpose of this exercise is that you can go through the flowchart and figure out what method you should pick. Okay, so step 1, GCF. Is there a GCF on this first problem? No, there's not. Step 2, do you have 2, 3, or 4 terms? Well, we have 4 terms, and because we have 4 terms, you need to use grouping. Now, I'm not going to factor this for you, but if you want the answer, I will put the answer down here at the bottom so that you can work it out on your own. The next problem, is there a GCF? Well, yes, there is. Now, I can't continue until I actually do the GCF problem, so I'm going to go ahead and do the GCF of 5 and factor that out. Now I'm trying to factor inside here. 2, 3, or 4 terms. Well, there's 2 terms, and because there's 2 terms, you know it has to be a formula. Which formula is it when we have r cubed plus 1? Well, this is going to be a sum problem, and because there's a little 3 here, this is going to be a sum of cubes problem. Again, I'm not going to work it out, but I'll put the answer at the bottom. Our next problem, on our next problem, is there a GCF? Well, no, there's not. So now I ask myself, is there 2, 3, or 4 terms? Well, there's 3 terms. So because it's a 3 term, I'm going to have to ask myself one more question. Is a equal to 1? Well, yeah, it is. So because a is equal to 1, this is an easy trinomial. But in this particular case, where it's an easy trinomial, where I'm looking for 2 things that multiply to negative 11 and add to 3, negative 11 is prime, so the only factors of negative 11 are 1 in itself, 11, and that's never going to add to 3. So even though this is an easy trinomial problem, it turns out that this answer is actually prime. On this next problem, I have a GCF. Step 1 says, is there a GCF? And there is. Once I factor out the GCF, then I look inside. Do I have 2, 3, or 4 terms left? Well, there's 2. Because it's 2 terms, it's got to be a formula. And which formula is it? Well, it's a subtract, so that means it's a difference. And because a is being squared and a1 is a perfect square, it's a difference of squares. On the next problem, is there a GCF? No. 2, 3, or 4 terms? Well, there's 3 terms. And is a equal to 1? Yes, it is. So that means it's an easy trinomial. And I'm looking for 2 numbers that multiply to 3 and add to 4. The next problem is there a GCF? No, there's not. Step 1. Step 2, 2, 3, or 4 terms? Well, there's 2 terms, which means it has to be a formula. Which formula is it? Well, because there's a minus, we know that's a difference. And because there's a little 3, and 125 can be rewritten as 5 cubed, we know it's a difference of cubes. On our next problem, is there a GCF? Nope. For step 1, there's no GCF. Step 2, 2, 3, or 4 terms? Again, there's 2 terms, which means it's got to be a formula. Because there's a minus, that's going to be a difference formula. A difference of, well, both of these are perfect squares, and x is being squared, so it's going to be a difference of squares. On our next problem, step 1 says, is there GCF? And there is. So I have to factor out a 6x first to see what else there is to factor. So then I have x minus 1. Well, inside the parentheses, I only have 2 terms. Because there's no squared, these are linear terms, and this actually can't factor anymore. So this was a GCF only problem. Now, is that prime? Is the answer prime? No. Some students will factor the GCF out and they're like, oh, it doesn't work anymore, so it must be prime. No. GCF is a form of factoring, so even if it's GCF only, that's going to just be your answer. On this next problem, is there a GCF? No, no GCF on this problem. 2, 3, or 4 terms? Well, this looks like there's 3 terms. Is it an easy 3 or a hard 3? Well, because 14 is not equal to 1, this is what I would call a hard trinomial. Because a is not equal to 1. So you're either going to use guess and check or the AC method. On our next problem, there is no GCF for step 1. Step 2, you have 1, 2, 3, or 4 terms. Well, in this case, it's 3 terms. Is a equal to 1? Yes, a is equal to 1. So this is what we call the easy trinomial. And you're just looking for two numbers that multiply to 15 yet add to 10. On this answer, we have x plus 5 times itself x plus 5. Another way of writing that is x plus 5 squared. Just in case you see it that way, I need you to understand that these are both the same, and you'll be given credit for either answer. On our next problem, we have no GCF. 2, 3, or 4 terms. Well, there's 2 terms here. And we have 9m squared, that's a square. 16n squared, that's a square. And because we have a plus, we have a sum of squares. Now, there is actually no formula for sum of squares. So this means if you ever have sum of squares and there's not even a GCF, that means my answer is going to be prime. There is nothing that's going to factor out of that whatsoever. On our last problem, it looks like we have a GCF of x minus 1. So once I factor that out, I'm trying to now factor the leftover trinomial. 2, 3, or 4 terms, there's 3. Is it an easy 3 or a hard 3? Well, the leading coefficient is not equal to 1, so this was what we would call a hard trinomial. And you're going to use either guess and check or the AC method. So I hope that little exercise helped you to figure out which method you are going to use. You could always pause the video and see if you can get your answers yourself. I gave you all of the solutions at the bottom, but this part is really important to understand when you use which type of factoring.